My name is Matt. In this video series, I think it's going to be a series, I'm going to make a Rubik's Cube solver using a recurrent neural network. And I'm gonna video the process because I think talking to someone about your ideas generally makes it easier to understand what you're doing, and in lieu of someone to bounce things off of, I think making a video to document the process is helpful, and I would normally talk to myself about it anyway. So I thought that it would be fun, in addition to making the actual project, to actually record it, record like my thoughts about it. So in terms of how this is going to work, the idea is I want to produce, and I'm going to go from the highest level of what we're trying to do down to the lower level of how it actually works functionally. The idea is going to be that we would be able to pass in a string value representing the state of a Rubik's Cube, and I assume that, this is one of the things I'll have to figure out, I assume that there is sort of a standard notation for describing a Rubik's Cube. So given any possible combination of color shifts and organization of squares, you could describe that using a, I guess, like 9x6 digit string. That would be probably the most efficient one. So 54 characters, because there are 6 faces on a cube and then there are 9 squares on each face. So you need to describe somehow, depending on where you started on the cube, what color each of the squares was, and based on that configuration information, we want our neural network to spit out a sequence of moves that describes how you need to rotate the cube in order to get back to a solved cube. So in terms of how do we do that, I'm going to go to my pad here and start brainstorming. So as I said, Rubik's Cube solver with recurrent neural network. So what is a recurrent neural network? What is a regular neural network? How do they differ? Good questions. I feel like there are some topics in computer science, or really probably anything, that no matter how many times you go over it, they just don't quite stick. And I mean, it's funny that the concept of a neural network is something that doesn't stick with me, because like the whole idea of a neural network is that it's about developing neural connections between things and essentially, well, not remembering things exactly, but kind of understanding concepts by making associations between things. But anyway, basically, I've heard a neural network, the best explanation I've heard, the best way to describe it, is as a general function approximator. So the idea is that for anything that you want a function to do, you could have a neural network basically stand in for that function. So if you wanted a function that just squared a number, like f of x, and the output is x squared, you can have a neural network that takes, and this is a very inefficient way to calculate the square of a number, obviously, but you could have a neural network that, given the input of 2, gives you 4, just by training it on examples of, every time I see the label 2, the data is 4, and you use the process of training and the back propagation to like adjust the weights in the network in order to basically make the most likely outcome of the network the number 4, and the same for all the other integers. 3 gives you 9, 4 gives you 16, that sort of thing. And so instead of designing the internals of the function, which is what you would typically do in programming, you would say, if you wanted to write a function kind of in a high-level programming language that squared a number, you would say, for f of x, return x multiplied by x, right? That would be basically a function that squares that squares a number. So like if we were to define the function f of x and x times x is your return value, like that is a function that just gives you a square number. Now the difference with a neural network is that you still have inputs, right? So you would pass into the neural network an input, a piece of input data. But then instead of having a defined sort of internal operation, you would have kind of a black box. Like it goes into this black box here, which is the neural network, and then the neural network gives you out your answer. And the whole idea of training is that we want to make the internals of the neural network, which sometimes kind of look, I guess in this case we'd have one point of input, but then who knows how many hidden layers, and then you have one point of output. We want to make, through training, the weights of this neural network such that they produce an answer that typifies what the square value of x is. So yeah, I mean, and that's like obviously not a very sensible solution for something as simple as calculating a square, but for something more complicated like solving a Rubik's Cube, maybe it does make sense. Maybe it still doesn't. Maybe I actually don't know how to solve a Rubik's Cube in terms of, like, I believe there is a procedure you can follow for doing it. I don't know what it is. It doesn't interest me that much to understand it. I don't think I would need to know. But in any case, we're not going to make a procedure for it. We're going to do it, using a recurrent neural network. So that's what a neural network is. How does a recurrent neural network differ? I'm probably going to butcher this explanation, but the idea is that in a standard neural network, you have one token of input, and then you get one output, or well, maybe token's the wrong word, but yeah, you basically, one thing go in, one thing come out. Like that's the idea. If we're talking about a recurrent neural network, though, it looks more like, this sort of a thing. Like we have like some input that goes in to begin with. The neural network processes that input. It outputs what it outputs, and then the output forms the new input, and it goes around and round and round like this until it reaches some sort of end state. And so the idea in this project is going to be that the initial input we give to the recurrent neural network is so initial input, can't write for some reason. Initial input is going to be some state of Rubik's Cube, and then like the first output, I imagine what it will be is like a given rotation. So the first step you need to take to finding or to solving the Rubik's Cube. So first output will be a rotation which brings cube one step closer to solution. So then with that output provided, you then, I guess, I'm not sure exactly how this would work, but presumably what you would do is pass in the new state of the Rubik's Cube. So second input, I guess, would be state of cube after making first rotation, right? And then And then what we're left with, and then not what we're left with, but then the second output will be the next rotation you need to make. Next rotation, right? And then so on and so forth until eventually we get to a solved Rubik's Cube. So, lost my pen. Solved cube. So, I think, I feel like I might not have explained that very well, but the idea is that the difference between a standard, a more typical neural network is like you get one input and then you get basically one unit of output. But in this model, what we want is to give it one input, the neural network processes that input, produces one output, and then based on that output, it goes through the cycle again and produces another piece of output until it reaches like its end state. So one question I have, which I don't have an answer to at the moment, is how do we define the end state? Question mark. I don't know. I suppose there are probably lots of hacky, obvious ways you could do that. Like, for instance, just compare the state of the cube to the solved state. Like, that is probably a pretty obvious way to do it. But I don't know. We'll have to figure that out. Provided I've otherwise got those details right, they're probably a little bit off, but something like that. I think in terms of the implementation details, the way I imagine this working is that we're going to do this in Python because Python's the language I know the best. So Python simulation of Rubik's Cube. Right. So I think Python, a better programmer than me could probably find a way to make this work, but I'm not aware of how you would do a 3D animation in Python. I think like Pygame, which is kind of the go-to interface, I think, in Python is generally just 2D, and you can probably make it do 3D if you're very clever, but we're not going to worry about that, or I'm not going to worry about that, because it seems like too much work. And like there are probably even like ways you can do this in JavaScript. I imagine like 3D JavaScript or something. You could definitely do it in like something like Unity with C#, but I don't know C#, and I don't have Unity installed even, I think. So anyway, we're going to do it two-dimensionally, which is fine because it doesn't matter. And also, the benefit of using Python is that like pretty much all the best machine learning libraries are in Python. I think there are like other versions you can get in C# and stuff, but again, I don't know how that works. So gonna use Python, gonna make a 2D kind of interface that looks something like, I guess we'll have a big screen divided into 6 bits, and each bit will be a side, and then each side is going to have it's going to be comprised of like 9 squares, and then each square is going to be have a label. I guess you probably need like again, this is like a question about notation. So how are those notated? I'm sure that someone else has already invented notation for a Rubik's Cube, so I will look up how to do that. But yeah, presumably, like, if this is the 4th cube, like, this will be 4-1 or something. This will be like, like in here, maybe we have like, maybe this is like 4A or something. I don't know. And then 4B, etc. And then 4A has a color. So, maybe it's like 4AR is 4A, something like that will be possible. And then, what we need to do in order to train a neural network is to have a bunch of training examples which basically show the neural network what output we want it to give us for a given state of the cube. So I think the way we can do that is by randomizing the cube. So we'll start with like an ordered cube. So I'll make a new page, like how to train the network. So start with ordered cube, and then we're going to do like say 100 random rotations on it. So we'll have, again, I'm sure there's a syntax for like all the rotations you can do, but basically there are three rows and 3 columns, and you can rotate it left or right. So like if it was like, we'll do like, say, do 100 random rotations. So for instance, rotate row 1 left, etc. And we do that 100 times. And so at the end of that, what we'll have is a Rubik's Cube that has an apparently random state, because the colors will be all mixed up, but we will know exactly how we got there, importantly, because we'll know all the moves that we took to get there. So you have like, result is 100 moves and a random state. So what effectively that does is it means we know how to solve the cube from that particular state. So what you could do with that information, I believe, is flip the order of the random moves, and then for that given random state, the neural network could see what move it needs to take. So, but more than that, I think what you have is not only 100 random moves and a random state, but also 99 random moves and a random state, and 98 random moves and a random state, and so on and so on. And so you can see like we've just collected a huge amount of training data, which the network could be trained on. So, so I'll just make a note. This creates training data for network. So then, once we have the training data, all we need to do is basically give the network, we can create a data set where we say like, given this state of the cube, which will be, that notation for whatever the 56 or however it is defined, 56, 54 digit string or however the notation works for the state of the cube, and then the corresponding move that it needs to take. Move or moves. I'm not sure if you would need to pass in, like, if the data would need to contain just the immediate next best move, or the entire sequence of best moves after that. I don't know. So I'll leave that here as a question. Question: does network need all moves or just immediate next move? I don't know. So we'll figure that out also. And then with the magic of, I guess, TensorFlow probably, I will admit I'm like never really sure which library to use, but I think TensorFlow allows you to do recurrent neural networks. I could be very wrong about that, but with the magic of one of these libraries, which is going to do all the hard work for us, we'll pass that data into it, hopefully train the model, and then it should be able to given just a random example we would generate, give us back an ordered cube. And we'll have our recurrent neural network Rubik's Cube solver. Yeah, I mean, that's the basic idea of it. I think that's kind of like a good amount of detail. I suppose, I mean, yeah, I mean, we can get into the implementation details some more in the next video, I think. But that's kind of what I have in mind. And it'll be fun to try and figure out the rest of it from here. So, yeah, I'll see you in the next one. Thanks.